right. So today we're still working with series and sequences. We're working with arithmetic series, a sequence pattern of numbers separated by commas. We did that. Today we're working with series. A series is a sequence of numbers separated by pluses or minuses. 1 plus 2 plus 3 plus 4 plus 5 plus 6 and so on. Now the ones we are dealing with in this class, they will have an ending. They will have a starting, they will have an ending. In Algebra 2 and in other classes and a lot of them I've worked with, you can actually work with an infinite series. 1 plus 2 plus 3 plus 4 plus 5 and so on forever. And depending upon that series, you can still add them all up. Even though you're adding an infinite number of numbers, you can still add them up and get a finite answer, which is really kind of hard. Okay, we don't do that in here, so you don't have to worry about that. But we will be adding them up. We have some formulas. Arithmetic sequence formula review, which we did before. How to find the next number in the sequence. It works for a series the same way. Arithmetic summation notation. So this is a summation. That's called sigma notation. This is the Greek letter, capital Greek letter sigma. Okay, that's called sigma notation. Sigma notation means you add them together. So I take the first number plus the second number plus the third number plus the fourth number. And the numbers are generated using that formula. And you start with the first number to the last number. And we will work with that today. One of the ones you're going to need to understand and know how it works. And then there's the arithmetic series formula, which you've seen everything that's here except for S sub n. It's the sum of the numbers. I want to add all the numbers together in that series. That is a formula that lets us find all of them together. Okay, and that's what that last new formula is. But we know the first number, the last number, the number of terms. S sub n is the only first new thing in that formula, and that means it's the sum of the first n terms in the series. So I will have a formula. I want to add up the first 20 numbers. I know how to add up the first 20 numbers. Okay. Now, at the bottom of your page, okay, find the sum of the first 100 whole numbers as Carl Gauss did when he was 9 years old. Now, Carl Friedrich Gauss is one of the top 5 mathematicians that ever lived. This guy was freaking brilliant. We use stuff today that is still named after him in mathematics, stuff that you may not see. If you work a little higher up, you would see some of the stuff in particular. He was brilliant. He was also a very generous mathematician that he was always helpful to other mathematicians. Mathematicians would write him letters saying, what do you think about this? And he'd answer them. That didn't always happen. He was more than happy to share the glory.
By any chance, is he the Gauss rifle?
No. One of the ones that he helped was Sophie Germain. You got to realize Carl Gauss was in the 1700s or so, and female mathematicians were not exactly looked upon as being able. Women, sorry, don't hurt your little pretty little heads doing stuff like that. That's the view that they had, which is bad enough for women in science and math now. Think about how bad it was 300 years ago. Okay, he wasn't like that. Sophie Germain wrote to him using another name. Eventually, he found out that it was this woman that was corresponding with him. And his first response was, why didn't you tell me? I got no problem with this. I'll be glad to help you out, because I know it's really hard. I'll give you extra help. That was his response when he found out it was a woman that had been writing to him, pretending to be a man in the letters. Because he didn't care. He obviously recognized that this woman was very intelligent and very good. And he supported her. That was not the usual thing. Other people, when they found out, would even talk to her afterwards. He wasn't that way. He was actually, until Germany went on the euro, he was the face, it was his face that was on the 5 mark. Okay, the equivalent of our $5 bill. A mathematician on a $5 bill. That's kind of cool. Now the story is, when he was 9 years old, he was a little kid, he's in a little schoolhouse, and the teacher said, okay, here's what I want you to do. I want you to take 1 plus 2 plus 3 plus plus 98, plus 99, plus 100. I want you to add those all up. When you're done, put your answer on my desk. And they all had little slates, their own individual little chalk pieces. And she's like, good. I can go have a cup of coffee, I can relax, get some grading done. It's going to take him a while to do this. Well, in less than like a couple of minutes, here's his 9-year-old kid. Here you go, what do I do now? And this is what he did. He looked at it. He didn't start adding them together. He looked at it and he goes, wait a minute. If I take the first number and the last number and I add them together, what do I get? I get 101. And if I take the second number and the next to last number and add them together, what do I get? I get 101. And if I take the third number and add it to the third from the end, add them together, what do I get? I get 101. And I do that all the way down to the 2 in the middle, and I add them together, what do I get? I get 101. How many pairs of numbers add up to 101? 50 pairs times 101 add up to 550. That's what he did at 9 years old. Kind of makes you feel a little small and insignificant, doesn't it? But like I said, he was truly gifted. He had a gift for seeing patterns, and that's what that was. But that's what he did. Sorry, 5,000. It should be 5,050. 5 times 101 with a 0 slapped on it. Okay. That's what he did. And this is very similar to the formula. The number of terms divided by 2 times the first one plus the last one. 100, 1 plus 100, 101. 100 terms divided by 2, that's 50 times 101. That's what he did. So if we were to do this using not doing it in his method, but using the formula, I had the first 100 terms. The first 100 terms added together. 100 divided by 2, the number of terms divided by 2, times the first number plus the last number. That's what you get. Okay? So, in order to add a sequence together, a series together, I need 3 things. I need the first number, I need the last number, and I need to know how many there are. So I look at this one here. Well, I have the first number. I have the last number. But I got to figure out how many there are. In order to do that, we go back to our old friend that we used in the first one. Figure out what n is. First term, last term, and D. D is for our difference. How do I get from one number to the next? What am I doing? I'm adding 5. So my D would be 5 in this case. So I take the last term, 99, is equal to the first term plus n minus 1 times our difference, which is 5. Okay. Solve for n. Subtract 4 and distribute to 5. 95 is equal to 5n minus 5. Add 5 to both sides. 100 equals 5n. So n equals 20. So we have 20 terms we're adding in together. Okay. So my total sum, 20 divided by 2 times 4 plus 99. And then this one's easy enough to do in your head, although you will want your calculator for a lot of stuff you're doing here today. 4 plus 99 is 103. 20 divided by 2 is 10. 10 times anything, is that something with the 0 on the end? That adds up to 1,030. That's a whole lot easier and faster going. 4 plus 9, that's 13. 13 plus 14, that's 27. 27 plus 19, that's oh my God, I'm already getting stuck. Okay? But that's what you're essentially doing. Same thing, get you the same answer. It's a lot easier though. Okay? Okay, so in this one, same idea. I know what n is. I know what the first term is, but I need to figure out the last term, don't I? So I need to figure out what the 190th term is. So I have to, before I can do this, I need to know what a sub 190 is. Once again, we go back to our formula for arithmetic sequences. It's the first term, negative 9.3, plus n, 190, minus 1, times d. So what's our d in this case? 1.5, positive 1.5. Once again, calculators come in handy. To find it, take 1, subtract the 1 in front of it. That'll give you what it is. Do the arithmetic. A 190th term. Let's see. 189 times 1.5. Ooh, got to turn it on first. That helps. 189 plus negative 9.3. I can't be right. Times 189 plus negative 9.3. Okay, 974.2 is what I get. That shouldn't be right, should it? Because we got a pattern here. 9, 3, 8, 3. It should be, because you're doing 0.5 each. Oh, wait. When we go to flip from negatives to positives, it'll change. Yeah, never mind. It is right. 274, my bad. 274.2. No, I'm sorry. The switching from the negatives to the positives, that'll screw up. It'll make it 0.2. So we know our last term, we know our first term, we know how many terms there are. We can set this up. Our sum of the first 190 terms is 190 divided by 2 times negative 9. Horrible. Negative 9.3 plus 274.2. And I get 25165.5. That's what I get. Is that what you get? Everybody actually do this with me? Or are you all just waiting for me to write it down? Well, you're going to have to do it on your own at some point. This one's a little trickier. Okay. This one's a little trickier. Seeing the pattern is not as easy to do. Now, we have our wonderful calculators that will let us do what we need to do in mixed number form. Okay? Our calculators will work this out and give it to us in mixed number form. I hate that, but we can do it. We got to figure out what D is. So I take a number, and if you can type in a calculator, your calculators, my calculators that you're borrowing, will do mixed fractions. You just have to hit the fraction key twice. So I want to type in 3 3/5 and subtract 6 1/10 from that. Do 3 fraction key, 3 fraction key 5. That's 3 3/5. minus 6 fraction key 1 fraction key 10, and I get negative 5 halves. That's what it comes out to be. Negative 5 over 2. Yeah. And I want to test it. If I want to, I can test that out. So 6, 1, 2, 18 fifths. Yeah, that works. It does. So my D is negative 5 halves. And I can leave it as mixed numbers or improper fraction. And actually got a really cool key on here that'll let you change that to a mixed number if you want to. It's the same one that does the fraction. It's generally right above it or right next to it on mine. It's right next to it. On yours, it's right above it. And I'll switch it back and forth between mixed numbers and improper fractions. Because I need to do this because I need to find my 16th term, which means I need to go back to here. Because what do I need to find the total? How many there are, first one and last one. I know how many there are, there's 16. I know what the first one is. What do I need? I need the last one. So, the 16th term is my first term plus 16 minus 1 times negative 5 halves. And I end up getting, you're going to love this one, negative 33 and 9/10. So that's my last term. Set up for the sum of them, set up for the sum. The sum of the first 16 terms, 16 divided by 2 times the first term, 6 and 1/10, plus the last term, negative 33 and 9/10. And I get negative 222 and 2/5. You did it all on this wonderful tool, your calculator. Learn how to use it. It's muy importante you know how to use your calculators correctly. Your turn, do those. And, oh, looky, the nasty one's going to be decimals. Not that hard. Okay, so I took a second, what you were green, to figure out what n was on the first two. Set it up in the formula. First one you get n is 16. Second one you get n is 50. But you ought to be able to figure that one out. 2, 4, 6, 8, 10 to 100. I'm counting by 2s to get to 100. That's 50 times. And you should be able to get that one out. Necessarily putting it in the formula. Doesn't matter. The bottom two, I went ahead and figured out what the 342nd term was and the 75th term in this one. Once again, those two parts are going back to what we did on the second day in this chapter, doing what we've done before in the second day, using this first formula for arithmetic sequences. Okay. The new part is plugging into the formula to get the total. So I always need three things. I need to know how many terms there are, 16. So I take the number of terms divided by 2 times the first number plus, not 115, 155. The last number. So 8 times 160, and I get 1,280. Here I need the sum of the first 50 terms. 50 divided by 2 times 2 plus 100. So that's 102 times 25, which is 2550. The next one, I haven't figured out what the last term was. So I find the sum of the first 342 terms is 342 divided by 2 times 10 plus negative 1,023. So 342 equals times negative 103. And I get, it's a big one, negative 173,223. Adds up in a hurry. And the last one, the sum of the first 75 terms, 75 divided by 2 times 11.6 the first term, plus 30.1 the last term. And I get 1,563.75. Yes.
I have 105 or 102.
Oh, which one? This one? That one?
Second one.
Second one? This one?
Yeah.
For the third for the term?
Right. 17 or 75.
Yeah, 75th one.
On that one,
Yeah.
wouldn't it be 101.3 because we add 10 to it after? Like, because if we...
Yeah, 101, negative 101.03. So when you add these together,
No, before that, when you work it out, wouldn't it be negative 101.3, not 1.23?
let me double check. This is entirely possible that I took it in wrong. So 341 times negative 3. And you're right, I did not add 10. Thank you very much for pointing out my folly. Oops. Thank you for catching my mistakes. Sorry. 10 times 3, 4, 2, 2. And so this one actually ends up being negative 171,513. Always one. Always one. But that's okay. I'd rather have you catch me make a mistake now and fix it now rather than later. Or let it go and then it shows up as being wrong for everybody. Okay. Questions? It's probably the hardest thing, looking at what we're doing, probably the hardest. Okay. This one is kind of along the same lines. We're going to put it in summation notation. So what we're going to do is we're going to rewrite this in epsilon notation. We're doing this one here. Okay. So I need to know a couple of things. I need to find my formula. So I need to find D and A sub 1, and I need to simplify that formula first. So D on this one's pretty easy. How do I get from the first to the second term?
2.
I add 2. So it's A sub n, that formula, okay? My formula for the summation notation is 2 plus n minus 1 times 2, because my D is 2. Okay. simplify that down, distribute the two, combine up like terms, and this one's actually really easy. Simplifies to 2n. Okay. Now, our sigma notation. Got to draw a sigma. N goes from, and this is how you say it, N goes from 1, and then at the top I put the last term number. What is N for my nth term? I don't put the number there. I don't put 3 on top. I put how many terms? First term, second term, third term, fourth term, and etc. So I got to figure out what term number the 30th term is. Does that make sense? Which means we once again go back to our formula here and figure out what N is. It's not that hard with this one. If I'm counting by 2s, the 30th term is which one? 30 is which one? It's the 15th. Right? 2, 4, 6, 8, 10. If I'm counting by 2s and I get to 30, 30 is the 15th number of my sequence. So it's 1 to 15 of my formula, 2n. That's it. All that is to that. Let's see. Yes. Move these down to give me some more room. That's it. That's sigma notation. That's summation notation. Find the formula, where you start to where you end.
So that's the answer.
That's the answer. That's it. I'm not adding up. I'm just rewriting it. These two are the same thing. They're the same thing written 2 different ways. That's it. All we're doing is rewriting it in a different format. Okay. So I have to figure out what my formula is. I have to figure out what my term number 305 is. What is N for that? I got to figure that out as well. So I need to know D. How do I get from 125 to 140? I'm adding what? 15? All right, D is 15. So I need to come up with my proper formula. The first term plus N minus 1 times D. And you simplify that out. It actually works out pretty good. 15N plus 110. So that's my equation I'm going to put with my sigma notation. Then I got to figure out what term number 305 is. So that means I set it up. I go, okay, 305 equals 125 plus N minus 1 times 15. And I solve that for N. Something we've done lots of times before. Got to do it again. You're going to be really good at this by the time we get done. 305 minus 125 plus 15 divided by 15. And I get N equals 13 for mine. What? You're looking at me funny. Of course, everybody always looks at me funny. N equals 13. So 305 is the 13th number in the sequence. So my notation. N equals 1 to 13. I go from 1 to 13. And my formula is 15N plus 110. Same process for the next two. Okay. Find your N, find your D, set up the formula, go from there. Okay. It's the same process. Do those two. Okay, so the first one, D is 7. So to find the formula, you use a sub 1, negative 26, plus n minus 1 times 7 gives you 7n minus 33. When you do that, you want to find what term number 51 is. 51 equals negative 26 plus n minus 1 times 7. So 51 plus 26. So I get 77 equals 7n minus 7. Add 7, you get 84. 84 divided by 7, you get n equals 12. So we needed this, and we needed this to write our sigma notation. N goes from 1 to 12 of 7n minus 33. Same process on this one. 42.6 plus n minus 1 times negative 1.8. So I get negative 1.8 n plus 42.6 plus 1.8. 44.4. And that's our formula we're looking for. We need to find out what term number 15.6 is. 15.6 equals 42.6 plus n minus 1 times negative 1.8. So 15.6 minus 2.6. Negative 27 equals negative 1.8 n plus 1.8. Minus 1.8 divided by 1.8. I get 16. So once again, we need to know how many terms there are. We need the formula when we get to there. It's easy. N goes from 1 to 16 of negative 1.8 n plus 44.4. Questions? It's a little bit tedious process, but it's not something terribly difficult. Just a lot of steps. Okay. Ooh, this is an easy one. Find the number of terms in the series. We're not actually adding them up. We just want to know how many there are. Now, when you start at 1, it's very easy. How many are in the first term? How many are in the first? In this first sequence, I start at 1. This is easy. I go from 1 to 8. So how many are there? There's 8. Zero to 20. It's not 20, it's 21. So we start at 0 and go to 20. We don't start at 1, we start at 0, so it's 21. From 3 to 9. There's a very easy formula. Take the top number, minus the bottom number, plus 1. 7. And if you look at the previous ones that did that, 8 minus 1 is 7 plus 1 is 8. 20 minus 0 is 20 plus 1 is 21. Top one minus the bottom one plus 1. 56 minus 2 is 54 plus 1, 55. 98 minus 12 is 86. 86 plus 1 is 87 terms. So quickly do the 5 on the bottom. 4 on the bottom. Sorry, 4. I can't count. There's 4. There we go. Yeah. Number on top minus number on the bottom plus 1. That's how many terms are in the sequence. I win. What do you mean I cheated? I didn't cheat. I didn't cheat. I did it in my head just to say, you're the first class I've done this one with. I didn't cheat. It's not like I got to memorize. So that's what you guys came up with, though, right? It is. It's really easy. Top one minus bottom one plus one. It's easy. Not everything that we do here is hard. Not everything we do here is hard. Some things are very easy. Okay, this one. Write out the first 5 terms. Okay, so what number are we starting with? What are we starting with n? We're starting with n equals 1. That means we plug in 1. The first term, we put in 1 for n. 1 times 2 plus 3. So my first term is 5. Plus my second term, 2 times 2 plus 3. 7. My next term, 3 times 2 plus 3. My next term, 4 times 2 plus 3. And my next term, 5 plus 2 times 3, or plus 3. Is this an arithmetic sequence or geometric? Arithmetic, and what's my d? D equals 2. So the next one, same idea. You only have to do the first 5 terms. You don't have to do all 10, just the first 5. Same thing, plug in 1 for n. Plug in 2 for n. Plug in 3 for n. So I get 6 minus 4, that's 2. 6 minus 8, that's negative 2. 6 minus 12 is negative 6. 6 minus 16, that's negative 10. 6 minus 20, that's negative 14. Dot, 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 because it does keep going technically for another 5 more terms, right? Arithmetic or geometric or neither? It's arithmetic, and what's my d? D is negative 4. You see a connection between arithmetic and geometric and our formula. What d is? Linear equation for the formula. D is the number times n. Okay. Next one's a little trickier, I will admit. Okay. Thank God you don't have to do the first 18. You only have to do the first 5. Put in 1 for n. 3 to the first is 3 times 2. Gives me 6. 3 squared is 9 times 2 is 18. 3 cubed is 27 times 3 is 54. 3 to the 4th is 81 times 2 is 162. No.
Yes.
Yes. And then whatever the next one is. What do you get? Did anybody do it yet?
Nope.
486. Thank you very much. I'm just too lazy to pick up my calculator. Arithmetic? Yeah. Good luck. Hit them where they ain't. Arithmetic or geometric? Is geometric. I'm multiplying each time times 3. R is 3. And look at the formula. Look what we get. Okay. So if I look at the next one, same idea. Plug in 1 for n and then 2, so I get 5 plus 25 plus 125 plus 625 plus whatever the next one is. I really don't care. Is this arithmetic or geometric? Is geometric goes up by what?
5.
R equals 5. Next one, same idea. 2 to the first is 2. 2 times 1/2 is 1. 2 squared is 4. Half of 4 is 2. 2 cubed is 8. Half of 8 is 4. 2 to the 4th is 16. Half of that is 8. And then half of that, again, the next one would be 16. Arithmetic or geometric?
Neither.
Oh. It's geometric.
How?
Multiplying by 2 each time. 2 times 1 is 2, 2 times 2 is 4, 2 times 4 is 8, 2 times 8 is 16. So R is 2. And if you look at the formula, that's a geometric formula. It has a power. 2 to some power times a constant in front. Remember when we were doing the recursive formula for geometric? This is a recursive formula for geometric. This is the recursive formula for arithmetic. They are tied in together. So if I do the last one, I get the same thing, and it is arithmetic. And D would be 3 on that. Do the top two. Do the top two. I want to be clear because this was just brought up, so I just turn on the recorder again. 1 through 10, n goes from 1 to 10. That means I've got 10 terms in there. The 10, putting 10 in gives me the 10th term, the last term. Okay? Putting in 1 gives me the first one. Putting in 10 gives me the last one. We're only looking for the first 5. So, because that's what the directions call for, the first 5. So, on the first one here, the first one is 2. And then, so I get 2, -1, right? Yeah, -1, and then -4, -7, -10. Right? And this one would be arithmetic, and D would be -3, because I go down 3 each time. This one, 2 plus 4 plus 8 plus 16 plus 32 plus blah, 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 blah. And this one is geometric, and R is 2 to the nth. Okay. We will work with geometric sequences next time a little better. The formula for that one, adding those together is nasty. Just forewarning. Find the sum. Add up the first 40 terms. Do I need to write down the first 40 terms? I need 3 things to find my sum. I need to know the first term, the last term, and how many there are. How many are there? There's 40. So I add up the first 40. So there's 40 terms. And that would give me 40 divided by 2 times, find the first term, plug in 1 to n. 3 times 1 is 3. 3 minus 8 is -5. Find the last term. Plug in 40 for n. 3 times 40 is 120. 120 minus 8 is 112. You need 3 things. First term, last term, and how many you're adding together. Okay. So 112 minus 5, execute, times 20. 2140. Next one's a little harder. How many terms are we adding together? We're not doing 14, because what number do we start with? We start with 6. We don't go from 1 to 14. We just need to add up from the 6th term to the 14th term. So how many are we actually adding together? 14 minus 6 plus 1, 9. Yeah, top minus bottom plus 1. 14 minus 6 is 8, plus 1 is 9. So we're adding together 9 terms. So it's the sum of not the first 9 terms, but the 9 middle terms. Plug in 6 for n. Figure out what our first term is. So it's 9 over 2. 1/2 of 6 is 3. 3 minus 3 is, what's my first term? 0. And that's okay. Plug in 14. 1/2 of 14 is 7. 3 minus 7 is Negative 4. So negative 4 times 9 over 2. Negative 18. Not that hard, is it? I mean, really, particularly those numbers. 0 minus 4. Actually, it's 0, yeah, 0 plus negative 4 times 9 over 2. You should be able to do that without your calculator. Let's do those two. Okay, so on the first one here, we are taking the first 56 terms. 56 divided by 2 times my first term is negative 1.9. My 56th term is 223.6. Add those two together. Times 56 divided by 2. And I get 6,207.6 is what I got. Second one, 79 minus 3 plus 1 is 77. So I have 77 terms that I'm doing on this one. So the sum of the 77 terms I'm adding together is 77 over 2 times, put in 3. I get 1 for the first number. That's easy. And then 7 minus 2 times 79, negative 151. So just 1 times 77 divided by 2, and I get negative 5775. Questions? Question? You got it? Okay. I don't mind getting it from somebody else as long as you get it and get it right. I don't care. Honestly, I don't care. Just as long as you get it right. Any questions? Because I do believe that's it. Ooh, yeah, that's it. Good.